Okay, so picture this. An AI doctor that can diagnose diseases with like perfect accuracy, but then it prescribes the wrong medication dosage because it can't quite grasp basic multiplication.
Yeah, it's kind of like they can write you a sonnet, no problem, but ask them to add up your grocery bill, and you're going to get some interesting results.
It's funny, right? They have this incredible mastery of language, but the language of numbers, that's a whole other story.
Yeah, and it's a big problem. As we start relying on AI more and more for these complex tasks, I mean, things that need language and number crunching, we got to figure out how to bridge that gap.
Which brings us to today's deep dive. We're looking at this really cool research paper, Executing Arithmetic, Fine-Tuning Large Language Models as Turing Machine.
Catchy title.
Right. But it's about this new approach, CAEF, that's kind of changing the game when it comes to AI and math.
CAEF, that stands for Composable Arithmetic Execution Framework. It's a mouthful, I know, but the idea is actually pretty simple. What if we could get LLMs to think like computers do when it comes to math?
Think like computers. So instead of just seeing patterns in data, they'd actually be able to understand the logic behind arithmetic.
You got it. They could solve problems step by step, just like we do, instead of just trying to pull the answer from memory.
It's like back in grade school, right? We learned addition, then multiplication building on those simple operations to tackle more complicated stuff. Is that kind of what CAEF is doing?
Exactly. It's like teaching an LLM to follow a recipe, where each step is a basic mathematical operation.
So instead of just knowing 2 times 2 equals 4, it would actually know how to multiply those numbers together.
Exactly. And because it understands the how, it can then apply that same logic to multiply any two numbers, even if they're 100 digits long.
Okay, I think I'm following you so far. But this whole thinking like computers thing, how do they actually make LLMs process math that way, step by step?
Well, that's where this idea of a Turing machine comes in.
Now, I've heard about Turing machines, but gotta be honest, always sounded a little intimidating.
It's actually not as complicated as it sounds. A Turing machine isn't like a physical computer. It's more of a theoretical model of how computation works. Imagine a set of instructions written on, say, a really long strip of tape. The machine reads and executes those instructions one by one. And by doing that, it can perform any calculation you can imagine.
So with CAEF, they're basically taking that model, that theoretical Turing machine, and using it to teach LLMs how to break down and solve math problems step by step.
Yeah, that's the gist of it. They're training the LLMs to act as if they are Turing machines specifically when it comes to dealing with math.
Okay, now that is fascinating, but there's got to be more to it, right? How does CAEF actually bridge the gap between this Turing machine framework and the way LLMs use language? So we've got this framework, the CAEF, teaching LLMs to think like a computer, working through math step by step, using this Turing machine idea. But in practice, how does it actually work? What's going on under the hood?
So there are two main parts to CAEF. The first is the executor. That's the part that actually crunches the numbers, does the math operation.
So if we're sticking with that Turing machine analogy, the executor is like the machine itself reading the instructions and then actually doing what it says.
Yeah, you could say that. It's been trained to follow those Turing machine steps for a specific math operation.
Gotcha. So that's our number cruncher. But LLMs, they don't naturally speak the language of math, right? It's all about words and sentences.
Right, which is where the second key piece comes in, the aligner. Think of it like a translator, bridging that gap between the LLM's language world and the more structured, mathematical operations. It takes the math problem, written in regular language, and turns it into something the executor can actually use.
Okay, so it's like giving the LLM a math problem, like what's 89 times 2 in English? And then the aligner swoops in and translates that into some code that the executor understands.
Exactly. And then, once the executor has done its calculations, the aligner translates that answer back into something we can understand. So it's doing double duty.
Like a whole team of interpreters making sure the LLM and the Turing machine can actually have a conversation.
That's a great way to put it. To really see how this works, let's look at a real example. Say we give the LLM that problem you mentioned, 89 multiplied by 2.
Okay, 89 by 2. I'm with you. So what happens? Walk me through it.
First up, the aligner kicks in. It takes that problem, 89 multiplied by 2, and translates it into our Turing machine language.
So it's breaking it down into those individual instructions, like add 89 to itself a certain number of times.
You got it. CAEF uses a counter to keep track of how many times to add 89. And this is really cool. It actually uses loops, just like in computer programming.
Loops. So it's like writing code in its AI brain to solve the problem?
In a way, yeah. It's using that simpler operation, addition, and repeating it within a loop until it gets the answer.
So it's not just recalling that 89 times 2 equals whatever, it's actively solving it step by step, following those Turing machine instructions.
Exactly. And to make sure it doesn't loop forever, it uses those less than comparisons we were talking about before.
Yeah.
It's checking, is the counter less than 2? If it is, keep adding. If not, we're done here.
Wow. So under the hood, it's this whole intricate dance of instructions and calculations, all thanks to CAEF. But did it actually work? Like, was it able to solve anything more complex than just 89 times 2? More than worked. It, like, aced it. We're talking near perfect accuracy, even with those 100-digit numbers. Even those big, fancy models like GPT-4, they kind of struggle with that, right?
And it wasn't just multiplication either. The researchers tested CAEF on, like, 7 different math operations.
Oh, wow. So what all were they testing?
Addition, subtraction, multiplication, division, you name it. Even those comparisons we talked about, greater than, less than, equal to.
Okay, so it's not just a one-trick pony. It's not just about memorizing a bunch of multiplication tables. It seems like it actually gets the logic of arithmetic, you know?
Exactly. Which opens up some really exciting possibilities for the future.
Okay, now you've got to tell me more about these possibilities. What are we talking about here?
Well, if we can use CAEF to get this level of mathematical understanding in LLMs, just imagine what we could do with other rule-based systems. Take music composition, for example. Music has its own set of rules, right? Harmony, rhythm, melody.
So instead of AI just like copying existing music, it could actually compose original pieces, like write a symphony that's totally new and never been heard before.
Exactly. Or think about those logic puzzles, the ones that really make you think. Those are all about following rules, making deductions. CAEF could give LLMs the ability to solve those puzzles, maybe even beat us at our own game.
And taking it even further, what about like scientific reasoning? Scientists, they follow a set of logical principles to form hypotheses, design experiments, analyze data. It's all very structured.
Right. Imagine if AI could not just analyze the data, but actually participate in that whole scientific process.
Yeah.
Making its own discoveries.
Okay, now that is just mind-blowing. But let's pump the brakes for a second. This is all still theoretical, right? There have got to be some limitations to what CAEF can do at this point.
Of course, of course. CAEF is a huge step forward, but it's still early days. For example, the researchers found that while CAEF did amazingly well on most problems, it would sometimes get tripped up by repeating number patterns, like a long string of 8s, let's say.
Huh, that's so weird. Why do you think those repeating patterns were such a challenge for it?
That's the million-dollar question. It's a bit of a mystery still. But it just goes to show that we've still got a lot to learn about how these LLMs process information, even with all the progress we've made.
It's like we've given them this incredible ability to think logically, but there are still these little quirks, these little glitches in their AI brains that we haven't quite figured out yet.
And figuring out those quirks, that's going to be key to building AI systems that are even more capable and reliable in the future.
So as we kind of wrap up this deep dive on CAEF, what's the one big takeaway you want to leave our listeners with? What's the thing that should really stick with them?
I think the biggest takeaway here is that we're just starting to scratch the surface of what AI can do. By teaching AI to understand the fundamental logic of something like arithmetic, we might be opening up a whole new world of possibilities, a world where AI can reason, problem solve, not just mimic human language.
It's like that old saying, right? Sometimes the questions are more important than the answers. And CAEF, it's giving us a glimpse into the future of AI, a future that's full of incredible possibilities, and a whole lot more questions for us to explore.
And who knows what other amazing breakthroughs are waiting for us just around the corner as we keep digging into these fundamental concepts.
Exactly. This is just the beginning of a very, very exciting journey. Thanks for joining us for this deep dive, everyone, and we'll catch you next time.